Hey everybody, it's nutritionist Amy Berger from toitnutrition.com, back to bring you the next installment in doing keto without the crazy. As always, thank you so much to my beloved YouTube viewers and subscribers. Thank you for watching. Thank you for sharing these videos far and wide. I hope they are helpful and educational. As always, also, my big disclaimer, we've got a big important topic today. I am not a physician. I don't treat, diagnose, cure, or prevent any medical conditions. This is just information and education. Okay, so today's video is going to be another bit of a longer one. Lots and lots of notes here, lots of scientific papers that are marked up like crazy that I'll be citing from. So I will be looking down a lot more than usual. I'm actually going to read directly from some of these papers because it's important stuff. Today's topic is about the Apoe4 gene or Apoe4 genotype. If you have no idea what this is or no idea what I'm talking about, I encourage you to watch anyway, because a lot of what I'm going to say applies to human beings in general, whether or not you carry this Apoe4 gene. So let's get into it, I guess. I don't pretend to know everything there is to know about this gene. I don't even pretend to know a lot, but I will share with you what little I do know. And when things are speculation, I will let you know it's speculation. And there's a lot of unanswered questions about this gene and what it means, but let's see about this gene and what it means. If you are watching this and if you kind of saw the title of it on YouTube and you tuned in because you're like, oh, I have E4 and I'm really worried about this, you probably tuned in because you're worried about it. And the reason you're worried about it is because having this Apoe4 gene increases your risk for things like cardiovascular disease, heart attack, stroke, and especially, most especially, Alzheimer's disease. My familiarity with this gene mostly comes from Alzheimer's disease. I wrote this book called The Alzheimer's Antidote, which is about using a keto or low-carb, high-fat diet as a nutritional intervention for Alzheimer's. And so a lot of what I know about E4 is specific to Alzheimer's, but it's not dissimilar to the same reasons it increases risk for cardiovascular disease and stroke and all that. So with regard specifically to Alzheimer's, so we get 2 copies of every gene, right? One from our mother, one from our father. If you have 1 copy of this Apoe4 gene, we call that heterozygous, you have 1 copy, you are at increased risk. If you are homozygous for E4, meaning you have 2 copies of the E4 gene, you are at super duper exponentially increased risk. You have something between a 50 and 90% chance of developing Alzheimer's. That is friggin' terrifying, I'm sure, if you are watching this, and especially if you have 2 copies of E4. However, in every talk I give about Alzheimer's, and I mention this statistic, I say, if you have a 50% chance of getting something, what does that mean? You have a 50% chance of not getting it, right? So what is it that flips the switch? This gene absolutely positively does increase your susceptibility to Alzheimer's, but it doesn't cause it. So what is it that's making that gene turn bad, or what is it that's triggering that increased risk? Nobody's genetically programmed to get sick. And I can tell you for sure that at least with regard to Alzheimer's disease, while the E4 does massively increase risk, it doesn't cause the disease, because you can have 2 copies of E4 and not develop Alzheimer's, and you can have no copies of E4 and still develop Alzheimer's. There's millions of people that have Alzheimer's disease that don't carry this E4 gene. So by itself, and millions of people that do have it that don't have the disease, so by itself, E4 is not causing Alzheimer's. There's something else going on. Now, I apologize, I will be looking at the notes a lot here. We'll talk about what ApoE is, what it does, and what it means, and then what to do about it. We'll get to what to do about it at the end, but let's stick with the nobody's genetically programmed to get sick kind of a thing. Any gene that is associated with an increased risk for some type of disease in the modern world, whether it's Alzheimer's or diabetes or cardiovascular disease or anything, is kind of usually just a mismatch, right? Genes that persist throughout the eons of evolution persist for a reason, and it's usually because at one point in evolutionary history, that gene conferred a survival advantage. Having that gene made you more robust, more resilient, more resistant to some disease that existed way back in that time. But in the modern world where things are so different, that gene is now a liability. And I think that this E4 is a great case of that. And the biggest example that you'll usually hear, and this is probably new to some of you, but it's really fascinating. People from certain parts of Africa, so some people of African extraction and African Americans in the modern world have increased. So they carry the they carry the trait, the gene for sickle cell anemia. Sickle cell anemia trait basically means that your red blood cells have like this sickle shape. They're not the normal shape of a red blood cell. That's kind of this like concave disc. Doesn't really matter what it's normally supposed to look like. The point is, people with sickle cell have a different shape to their red blood cells. Back in the day, back in the evolutionary day, in parts of Africa, that different shape of the red blood cell made it harder for the virus that causes malaria to infiltrate the cell. So they had like a higher degree of protection against malaria. So of course, that gene would persist. That's a really important thing to have if you live in a place where malaria is rampant. But in the modern world, where we don't really have to fight off malaria that much, if anywhere, not in the industrialized world anyway, where we don't have to fight off malaria, that sickle cell trait is a liability because it doesn't deliver oxygen as readily either. So like people with sickle cell tire out very quickly. They can't exercise long-term stuff. And there's other problems with it too. But that's the example of how something that at one time was a good thing in another context, in another time and place, is a bad thing. But I shouldn't say it's a bad thing. It's just a mismatch, and we might have to take some extra steps to have precautions against the problems that could potentially arise. And that's exactly what we're going to see here with E4. So same thing, sodium sensitivity, right? In most people, you could eat a ton of salt and your blood pressure doesn't budge. In some people that are what we call sodium sensitive hypertensives, their body does react to salt or sodium. Their blood pressure rises when they eat too much salt. A lot of these people are of African geographic origin or from very, very hot climates. If you lived in a very hot, very dry place, your body did you a favor. It was advantageous to your body to be able to store water, to hold on to water as much as it could. But in the modern world where we have much more access to water and maybe it's nowhere near as hot, some of these people are now living in Canada, they're living in Seattle, they're living in Norway. The advantage that their bodies had thousands of years ago to hold on to water in the presence of sodium is now a liability. Now when they have salt and they're not living in a very hot, very dry climate, they retain and the blood pressure goes up. So the human body is a beautiful thing. It doesn't do any of these things to hurt us. There's always a logical, totally sensible reason for what it does. We might not always know the reason. We might not have figured it out yet, but for sure there is one. Okay, what is ApoE and what does it do? So you have probably heard the word lipoprotein. You've probably mostly heard it talked about with regard to HDL, high density lipoprotein, and LDL, low density lipoprotein. And you know that these are the particles that carry cholesterol. HDL and LDL are not cholesterol. They are the particles that carry the cholesterol inside them. And we can think of them as like a ball with lots of little balls attached to them. So, did I lose my train of thought? These particles, these lipoprotein particles, my friend Dave Feldman from cholesterolcode.com likens them to cargo ships because they are the thing that's transporting stuff throughout the bloodstream. Like a ship on the ocean, these lipoprotein particles in your blood are carrying things like cholesterol, triglycerides, fatty acids, fat-soluble nutrients, things like vitamins A, D, E, and K, and the carotenoids, fat-soluble nutrients, are carried in these lipoprotein particles. Now, in order for these lipoprotein particles to latch on to their target cells, like they're traveling through the bloodstream, but they have to go somewhere. They have to go to your liver, to your whatever, your brain, your heart, your muscle tissues. They have to attach to the cell in order to release their cargo into that cell. ApoE and ApoB and other kinds of Apo are like the docking equipment. They help the lipoprotein particles dock onto or latch onto the cells. So Apo means apolipoprotein. That's what it's APO. It's like short for apolipoprotein. There are a lot of different forms. We are most concerned with apolipoprotein E here. We'll just call it ApoE. So, checking the notes. Okay, there are 3 different variants of the ApoE. So the ApoE gene encodes for the protein ApoE. It's like scientific jargon is very confusing. The gene, they capitalize the A in ApoE. The protein particle is little a, ApoE, lowercase a. So having the ApoE gene means that it codes for your ApoE, sorry, getting ahead. And I can't stop the recording because I'm already 11 minutes in. I don't want to have to redo this. Forgive me. There are 3 variations or variants of the ApoE gene in the human family, ApoE 2, 3, and 4. I don't know what happened to number 1. Maybe number 1 is in another species, but in humans we have 2, 3, and 4. And because these are proteins, they are long strings or long chains of amino acids. Individual amino acids make up whole proteins. These 3 variants of the ApoE protein vary by only 1 amino acid. The ApoE protein is 299 amino acids long, but the different forms, 2, 3, and 4, have only 1 amino acid difference between them. But do not underestimate the importance of this very seemingly small change. It's not small at all. In biochemistry, there's an adage that says structure determines function, meaning the way something is built determines what it does. It determines how it functions. So because these things are built differently, right? Only 1 amino acid different, but because of the magnetic charge or the polarization or the binding properties of each individual amino acid, having 1 different amino acid actually very dramatically changes the superstructure of the whole protein itself. So the ApoE 2, 3, and 4 apolipoprotein particles actually have a slightly different shape. Because they have a different shape, it affects how they bind onto the cells. It affects how they interact with the lipoprotein receptors that are sort of where those apolipoproteins need to latch onto in order to deliver all that good stuff. So that kind of explains a lot of the difference we see in disease susceptibility and in lipid markers and all kinds of other things that we can measure between these different genes. Let's see. ApoE3 is the most common in the human family. It's between frequency of between 77 and 78% of humans have ApoE3. ApoE4 is the second most common, between 14 and 15%, and ApoE2 is the least common, 7 to 8% of the 7 to 8%, not 78. ApoE2 is the least common. So a lot of people carry E4. Not everybody gets Alzheimer's. Not everybody gets a heart attack. So what's the deal? I said, okay, I'm gonna read now from some of these papers. You can see how incredibly marked up these are. These are some of the papers that I cited for my graduate thesis, which was on the topic of Alzheimer's disease as type 3 diabetes, which eventually morphed into my book. And I've held on to these copies all these years. I mean, I got my degree in 2012 because these are that educational, that informative, that fascinating. So let's read from this one regarding what ApoE does, what these particles or apolipoprotein particles do. Lipoproteins are lipid transport vesicles that ensure the solubility of lipids within aqueous biological environments. What does that mean? The blood is an aqueous environment, meaning it's watery. This is why like fat and cholesterol can't travel through the blood. It's like mixing oil and vinegar in a salad dressing. They just don't play together. You have to have some kind of an emulsifier. Well, instead of an emulsifier, our blood, our bodies use these lipoproteins that can travel and mix with the bloodstream. Well, not mix, they travel with the bloodstream to deliver these otherwise not mixable stuff that need to travel in the bloodstream. Apolipoproteins stabilize the surface of lipoproteins, serve as cofactors for enzymatic reactions, and serve as ligands for lipoprotein receptors, right? Ligands for that receptor, that ApoE particle, or an apolipoprotein particle, not just ApoE, serves as like the contact point onto the receptor. ApoE plays a major role in the transport of lipids in the bloodstream, where it participates in the delivery and clearance of serum triglycerides, phospholipids, and cholesterol. ApoE-containing lipoproteins are bound and internalized via receptor-mediated endocytosis by a number of proteins in the low-density lipoprotein or LDL receptor family, and LDL related protein families. These receptors may exhibit different affinities for the three common ApoE isoforms. This is what I said before. The different three forms, E2, E3, and E4, have different affinities, or the receptors have different affinities for those particles. If you have a lower affinity for that ApoE 2, 3, or 4, those particles are going to stay in the bloodstream longer, right? Because the receptor doesn't want it. They have a low affinity. If you have a higher affinity, it's gonna suck them up like a champ because it wants them. You will have less of this stuff in the bloodstream. Neurons, with regard to Alzheimer's, neurons express receptors for ApoE. Thus, ApoE may be involved in the delivery and clearance of cholesterol and phospholipids to, for example, neurons and myelin synthesizing oligodendrocytes. There's a lot of big words in there. The point is that what these apolipoproteins, these ApoEs do is help deliver stuff to all kinds of cells, to the brain. Some of these are actually synthesized in the brain. The astrocytes, I think, make some ApoE. ApoE is involved in the transport, delivery, and clearance of cholesterol and phospholipids in the periphery, meaning your whole body that's outside your brain and spinal cord, and in the brain. Let's see. ApoE isoforms may differ in their ability to deliver fatty acids and cholesterol to neurons, and blah, blah, blah. Let's see. That's enough of that for now. That is probably enough for you to know what ApoE does. So now let's dive into some really fascinating history on ApoE4. I'm just sorry, I am looking at the notes so I don't miss anything. Okay. It is believed that the Apoe4 variant of the Apoe gene is the oldest in the human family. I'm not sure if they've proven that for a fact, but it's sort of hypothesized that it's the oldest. And because it's the, well, it doesn't really matter whether it's the oldest or not for this purpose, but believe it or not, the Apoe4 gene was selected against in human populations with a longer history of grain-based agriculture. So I'm gonna read a couple things from that because it's too fascinating not to. This paper, High Carbohydrate Diets and Alzheimer's Disease by Sam Henderson, one of my all-time favorite Alzheimer's researchers. Well, they quote the exact same study in this one, which is also great. This is gonna be a long quote, but bear with me. Apoe4 allele frequencies are low in populations with long historical exposure to agriculture, suggesting that consumption of a high carbohydrate diet may have selected against Apoe4 carriers. People with the lowest frequencies of Apoe4 include longtime agriculturalists such as Greeks, 6.8%, Turks, 7.9%, Mayans, 8.9%, and Arabs living in northern Israel, 4%. Whereas populations with the highest frequencies include longtime hunter-gatherers such as African pygmies, 40.7%, Papuans, 36.8%, and Inuits, 21.4%. High carbohydrate diets have selected against the Apoe4 gene, meaning that this gene is not suited for a high carb intake. It wasn't suited for a high carb intake thousands, potentially millions of years ago, where they didn't have sugar sweetened soda and Pop-Tarts and Danishes and jelly and preserves and God knows what else we eat, literally liquid, powdered sugar. I think the Apoe4 gene is the worst match for the modern diet and lifestyle, right? It's the worst. The people who carry the E4 gene are the least suited for a very high carb diet. And so with regard to triggering increased susceptibility for Alzheimer's disease or for cardiovascular disease, for stroke, for anything like that, it's not that Apoe4 by itself causes any of that. It's interacting badly with a diet, and not just a diet, a whole lifestyle. There may be like that this E4 is suited to get a lot more sunlight, a lot more physical activity, whether it's like sprinting or just a lot more low-level walking. The life of a hunter-gatherer may be getting a lot more sleep, lower stress, punctuated by like mimicking high stress when like there would have been a predator chasing after you. But this is a hunter-gatherer genotype that is living in the modern world, right? I even have, there's a chapter in my book, the whole chapter 7, let's see where it is. My whole chapter 7, Apoe4, is there an Alzheimer's gene? And I have a section that's called, it might be hard to see. What does it say? The Apoe4 genotype and risk for Alzheimer's. Hunter-gatherers in a modern supermarket world. Because that is exactly the situation here. Apoe4 isn't killing you. Apoe4 isn't out to get you. Apoe4 is not suited for a diet that's like 60% carbs, let alone a ton of refined carbs. So again, from one of my all-time favorite papers, the Apoe4 allele may not be inherently damaging, but only in combination with a high carbohydrate diet, which is damaging in itself and is likely to be a major contributor to the high risk of coronary artery disease and possibly Alzheimer's disease in modern populations with or without the Apoe4 allele. And when I say allele, that means that's the variant of the gene. I should have clarified that earlier. That's just a big science word that means this type of gene. And Sam Henderson, like I said, my high carbohydrate and diet author, says the same thing. E4 is rare in populations with long historical exposure to agriculture, suggesting that consumption of a high carbohydrate diet may have selected against E4 carriers. Evolutionarily discordant high carb diets are proposed to be the primary cause of Alzheimer's disease. A change in diet emphasizing decreasing dietary carbohydrates and increasing essential fatty acids may effectively prevent Alzheimer's disease. Again, that is speculation. We don't know for sure, but let's see if I can, samey. Sam Henderson says the same. It should be noted that E4 is not an inherently damaging allele. It is only deleterious in combination with a high carb diet, which is deleterious on its own. Populations with little exposure to high carb diets have higher E4 frequency, suggesting it is not selected against in these conditions. There are tribes in Nigeria that have a very, very high frequency of this Apoe4 gene. And you know what they don't have? Alzheimer's disease. They have lots and lots of E4 among them. They don't get Alzheimer's disease because they live and they eat very, very differently to the way that we live and eat in the rest of the industrialized world. So back to my notes after those papers. Okay, something super, super fascinating about this gene. It increases risk for Alzheimer's. There's a lot of mechanisms why and proposed reasons why. If you want to know why, read my book or read some of these papers. Apolipoprotein E metabolism and functions in brain and its role in Alzheimer's disease. Like the research on this is endless. Like I'm not making it up. But if you've ever heard the phrase amyloid plaques or beta amyloid, if you've ever heard of Alzheimer's, research, there's a school of thought that believes this amyloid stuff is causing Alzheimer's. And I don't have time to get into the details. This video is going to be long enough already, but this beta amyloid is a protein that like builds up in the brain, and it builds up and cross-links upon itself, forming these infamous amyloid plaques. And these plaques actually block communication between neurons. The neurons are not able to communicate with each other because this amyloid is, for lack of a better word, gunking up the works. It's just like this massive tangled gunk in the brain. And that's, yes, that is oversimplifying, but you know, stay with me. The brains of people that are homozygous for E4, 2 copies of the E4, upon autopsy, and they do like a section of the brain, a slice, and they stick it under a microscope, you can identify somebody that is homozygous for E4 without a microscope, because that's how riddled with this amyloid plaque the brain is. So just looking at the slice with the naked eye, you can say that's an E4 because there's so much plaque. Do you know, and this is like I talk about this in my book, one of the things, and in the Alzheimer's brain, the problem is not that the Alzheimer's patient produces too much amyloid. They've never determined that people with Alzheimer's over-secrete amyloid. People with healthy brains secrete amyloid. Everybody's brain secretes amyloid. The problem in Alzheimer's is that it's not cleared away properly. And so because it's like the sanitation crew is on strike, the garbage men are on strike. So it just builds up and builds up. One of the things that's responsible for clearing it away, hang on to your hats, it's an enzyme called insulin degrading enzyme. Yes, that is exactly what I said, insulin degrading enzyme, or IDE. IDE degrades a lot of different things, and it's an enzyme. Hormones and proteins and neurotransmitters and stuff can't just stay in the blood or in the brain all the time. They have to be cleared away. So insulin degrading enzyme clears away numerous things, 2 of which obviously are insulin and beta amyloid. What? Yes, beta amyloid is cleared away by insulin degrading enzyme. And so when you have chronically high insulin, this enzyme IDE is too busy going after all the insulin, and so it's going to neglect all its other targets, including the amyloid. And having chronically high insulin is a huge risk factor for Alzheimer's, regardless of whether or not you have any E4 genes, regardless of your family history. If you are chronically marinating yourself in insulin all day, you are at higher risk for Alzheimer's, period, end of story. Why does this matter for Apoe4? Again, Apoe4s presumably are not suited for a high carb intake. Did you know people with the Apoe4 gene produce less insulin degrading enzyme? Now the thing is, I've written blog posts about this. Insulin does a lot more than regulate blood sugar. Way, way more. In fact, in my opinion, insulin is actually not a blood sugar hormone at all, or if it is, that's actually one of its more minor roles. I'll be coming out with a blog post about that soon, or by the time this video is live, it might already be published. But nevertheless, insulin is involved somewhat in blood sugar regulation. And we can speculate, and again, it is speculation, if the Apoe4 gene was forged in our hunter-gatherer times and it wasn't suited for a very, very high carb intake, especially not a high refined carb intake, right? Because some of those hunter-gatherers might have been consuming fruit, they might have been consuming honey, they might have been consuming even some starchy tubers. So it's not like they had a zero carb diet, but they certainly weren't getting 40, 50, 60% of their calories from carbs like so many people do in the modern world. So we can sort of reason that the Apoe4s produced less insulin. They didn't have to have such high insulin all the time to deal with all the glucose in their bloodstream. So if they were producing less insulin, they presumably had less of a need for insulin degrading enzyme. And again, I have to emphasize, like, this is just educated speculation, but it is educated speculation. I'm not just, you know, making shit up. So let's see, what else? So the Apoe4 doesn't cause disease. It does increase your susceptibility, but no one else is immune to this. People with E2, people with E3, they also get Alzheimer's disease. They also have strokes. They also have heart attacks. They also have cardiovascular disease. They also have type 2 diabetes. It's not like other genotypes are safe. And like, there's no genotype that is suited for, you know, Mountain Dew and Pixie Sticks and Twinkies. Like, I'm sorry to use brand names. If you're outside the US, no genotype is suited for sugar sweetened beverages and refined pastries and sugar and all that. So the gene, having ApoE4 makes you, it doesn't give you a risk for any disease that anyone else doesn't also have. It just makes your risk higher. You are more susceptible than the other genotypes, but they are definitely not immune. So if you're thinking, oh, I'm 2-3, like I had my E4 tested, I am E2, E3, I ain't protected against any of this stuff. So you've probably heard the phrase, genetics loads the gun, but diet and lifestyle pull the trigger. In my opinion, the increased risk that the E4s have for Alzheimer's disease is probably the single best example of that we have in modern medicine and nutrition. There's probably others that I'm not aware of, but that's the thing here. So if diet and lifestyle are pulling the trigger, what's the diet and lifestyle we would want for an E4? I'm not going to talk that much about the lifestyle because I mean, my specialty is the dietary piece, the nutrition piece, but I will just sort of reiterate what I said earlier, that if the E4 really is a hunter-gatherer gene, then you want to sort of mimic, to some extent, not like crazy, but to some extent, a hunter-gatherer life. You probably would get more sleep. You know, maybe even if it was broken, there's a lot of speculation that our hunter-gatherer ancestors had like polyphasic sleep. They would sleep for 2 or 3 hours, wake up, do some stuff, go to sleep again, wake up, do some stuff, go to sleep again, whatever. The point is, in total, they may have been getting more sleep. They probably got a lot more daylight, sunlight exposure, and dark exposure. Like when it was time for them to sleep, it was dark. They didn't have the router, they didn't have the alarm clock right next to their face, they didn't have light streaming in from outside into your bedroom. Possibly some fasting, you know, everyone sort of assumes that our hunter-gatherer ancestors went through periods of famine or fasting. We don't know that. And I'm going to credit my friend Amber O'Hearn. She's very well known in the carnivore movement. She goes by Keto Carnivore on Twitter. Super bright gal. She challenged Dr. Brett Scher in his Diet Doctor podcast, where, you know, he was kind of saying, well, you know, we know that we went for periods of time without food and we should fast. And she said, do we know that? I mean, a lot of that speculation. We don't know how long they went without food. But even if they didn't fast for like a week at a time, 20 days at a time, it's unlikely that they were snacking all day long and grazing all day long like we do in the modern world. So we can kind of assume maybe that type of grazing pattern, especially if you're grazing on carbs all day, probably not the best idea. You might not have to abstain from food 100% for 4 or 5 days at a time, but probably not best to have constant infusions of calories, right? What else? Exercise also possibly, like I said, they probably did a lot of low-level movement, a lot of walking, and punctuated by periods of sprinting and more like anaerobic work. So, but to the diet, let's move on to the stuff that I'm better at talking about. Dietary recommendations for ApoE4 sort of vary. You will most often hear, oh, step back. What we have to remember about any dietary research, any nutritional research, any epidemiological research, or actual intervention studies, when we're looking at the data, we have to keep in mind that almost all the findings we have are based on carb-eating populations, right? When most people, most research subjects, unless you're specifically doing a study on a low-carb or ketogenic diet, people are going to be eating the standard type diet, which is upwards of 40 to 60, if not more, % carbohydrate. So any findings we have cannot necessarily be extrapolated from carb eaters to non-carb eaters or very low-carb eaters. One of my doctor friends in the keto world has even suggested that somebody needs to write a paper about the new normal. A lot of what we consider normal, whether it's lab values or whatever else, different parameters we look for in the blood or in other measurements, those reference ranges are based on people eating high carb diets. We don't know what's normal in somebody on a long-term ketogenic diet or on a long-term lower carb paleo diet. They could be very different, so how a certain intervention affects a carb eater versus a keto eater could be very different. So let's keep that in mind because it's a big deal with regard to ApoE4. ApoE4 carriers are usually recommended to limit saturated fat, and especially on a ketogenic diet. And the reason for that is because when the ApoE4s eat saturated fat, their cholesterol skyrockets, the LDL skyrockets. It looks like bad news, right? Because you're like, your blood is all flooded with cholesterol. The question is, does this even matter? I recommend, again, my friend Dave's website, cholesterolcode.com, C-O-D-E, code, cholesterolcode.com. He is doing some absolutely phenomenal research with trying to get to the bottom of what the hell is cholesterol doing? What are lipoproteins doing? Does it matter if you have high cholesterol? Does it matter if you have a lot of particles? Because there's individual lipoprotein particles, and then there's the cholesterol in each individual particle. There's a lot of controversy right now over whether high cholesterol is any concern whatsoever in people whose insulin is low, blood glucose is low, triglycerides are low, HDL is high, blood pressure is normal, inflammatory markers are low, when everything looks really, really good. And the person looks fantastic, they have lots of energy, they're healthy, they have no complaints, they're at a normal weight. Does it matter that they have high cholesterol? Should we give a fly and hang? I don't know. A lot of us think no. Some people still think yes. I can't tell you what to think. I don't know for sure yet. I know which side I'm leaning toward. But so the reason ApoE4s are sort of scared away from saturated fat is because when they eat saturated fat, all these lipids go crazy. But we don't know that there's anything harmful about that whatsoever, at least in the context of a low carb or ketogenic diet. In my opinion, based on my understanding of the ApoE4 story, the number one most important thing to do if you are an E4 carrier is to keep insulin and blood glucose low. Whatever you have to do to accomplish that. Some of you might require a super strict keto diet. Some of you could get that way with just paleo or just primal low-ish carb. You might not have to be at like 20 or 30 grams of carbs a day. To me, that is absolutely the most important thing to do, is to regulate the glycemic and insulin impact of your diet. If you are concerned about the impact of fat, if you would like to hedge your bets just in case, you absolutely can construct a lower carb ketogenic diet with lower saturated fat. So your fat is going to come much, much less from dairy, slightly less from coconut oil. If you are dealing already with cognitive impairment or Alzheimer's, then I would recommend the coconut oil. If not, you probably don't need the coconut oil. Cocoa butter you want to stay away from. And you would get a lot more of your dietary fat from monounsaturated and polyunsaturated fats like olives and olive oil, avocados and avocado oil, nuts and seeds, fatty fish, poultry, pork, and also red meat. Things like beef and lamb, and especially ruminant, bison, venison, ruminant, wild game is even better. Everybody thinks that like pork and beef are so high in saturated fat because we heard that, right? Oh, lard clogs your arteries and beef, red meat clogs your arteries. Hello? Pork is actually higher in monounsaturated fat than it is in saturated. It still has a high proportion of saturated fat, but it has more monounsaturated than saturated. And the type of monounsaturated fat it contains the most of is oleic acid, which is the exact same special fatty acid that everybody celebrates. Olive oil gets that special halo because of all that oleic acid. It's the same exact fat in bacon and in pork and in lard and in all that delicious stuff. Beef also is almost 50-50. I think it has about equal. It might be a little more or less saturated, but it's still not. The biggest source of actual saturated fat in the modern diet is dairy. It's your cheese, your cream, your butter, and stuff that we have access to now, like coconut oil and palm kernel oil. So you can totally construct a low carb diet that will achieve the lowering of the blood sugar and the lowering of the insulin without a lot of saturated fat. What I would also recommend specifically for E4s, and this is just my opinion, like if it was me, because of the possible connection with that hunter-gatherer, history, I would recommend an emphasis on certain micronutrients too. So if you like fish, I would really recommend liberal intake of sardines and mackerel and salmon and anchovies. And so you're going to get a lot of those critical omega-3s, maybe some shellfish. You really want a lot of B12 if you're an E4. But of course you can get B12 from red meat and pork and all that stuff too. Another thing I would emphasize for the E4s that I'm not as concerned about for other genotypes, but you do you, right? Do your own thing, is the omega-6 and omega-3 balance between those, omega-3 and omega-6 fats, like I just talked about with the fish. I did a video previously on omega-6 and omega-3, so you can look for that. I think it's called Omega-6 is Not the Devil, so you can find that. And I agree with everything I said in that video, but there's always room for nuance. There's always room for gray. There's no black and white. If I had Apoe4, I would go out of my way a little more to avoid excess omega-6. And I say excess because omega-6 is actually an essential fatty acid. You can't avoid it entirely, even if you wanted to. It's in beef, it's in pork, it's in poultry. I mean, it's because we need it. And when you get it from those sources, you will get far less of it than you would from the things that I would pay more attention to avoid, like soybean oil, cottonseed oil, corn oil, grapeseed oil, I might have said corn oil, all those weird, nasty vegetable oils that you can either buy like in a big jug to fry with, or a lot of condiments, a lot of the salad dressings and marinades contain those. So if you're making your own from home, from scratch, or you're maybe buying, Mark Sisson has the Primal Kitchen line that really is only made from like olive oil and avocado oil, that's fine. So you can go much, much lower on the omega-6 and emphasize omega-3 from fish, shellfish, pasture-raised meats, egg yolks. If the hens consume feed that contains flaxseed or fish meal, their egg yolks will actually contain higher omega-3s. So that's perfectly fine advice for the other genotypes too. I don't think anyone should be eating a ton of omega-6. My point in the omega-6 video was that we don't need to be like terrified if we have a little bit of it now and then, especially in the context of a low carb diet where your inflammation's low and your glucose is low and your insulin is low and everything is great. What else can I say about that? So with regard to the Apoe4, I would say my number one priority would be controlling blood sugar and insulin. The type of fat, whether saturated or monounsaturated, is a secondary or tertiary issue in my opinion. But like I said, if you just want to take that precaution just in case, don't eat a lot of dairy, don't eat coconut oil, eat other foods. Totally. The beautiful thing about keto is that you can do it like any which way. You can have a very, very different type of intake than somebody else has, but you could both be keto, you could both be low carb. Let's see, what else? You might even also, as an Apoe4, want to get more vegetables than the traditional sort of low carb eater. I mean, to be clear, many of us low carb eaters eat plenty of non-starchy vegetables. But as an E4, you might have, and again, might have been more suited for like a lot of leafy greens, a lot of wild sort of plants like that. You don't have to, but I'm just saying you might be more suited toward like that sort of higher fiber, higher plant nutrient intake. Very controversial, I don't know. I'm going to end this. I think I've been rambling way too much. Let's see what's going on. Can I say anything? Oh, let me just couple more things. Maybe about the diet. Well, I already mentioned specifically that these researchers already know that the high carb diet is not really suitable for the E4s out there. Okay. Cha-cha-cha. A change in diet, emphasizing decreasing dietary carbohydrates and increasing essential fatty acids, such as DHA, may effectively prevent or delay Alzheimer's disease. Although, and they're talking about the link between obesity and cardiovascular disease and Alzheimer's and all this stuff. Although weight control is important in all people, it may be especially important in men with Apoe4 to modify, it may be especially important in men with an Apoe4 allele to modify potentially increased fasting insulin and glucose levels, right? So basically what they're saying, I sort of put the emphasis on the wrong thing. They're saying it's important to control your weight, but it might be even more important to actually have low insulin and low glucose. So high carb diets, what do? They inhibit fat metabolism, right? We know when you're on a low carb or ketogenic diet, you have the fat-based metabolism versus the carb-based metabolism. So the inhibition of lipid metabolism, of fat metabolism by high carb diets may be the most detrimental aspect of modern diets. Therefore, reducing dietary intake of high glycemic carbohydrates and increasing protein, fiber, and fat would be preferred. Yet, such a change would require dramatic decreases in carbohydrate intake to less than 30% of daily caloric intake and would be difficult to implement without drastic changes in dietary thinking. Yeah, Sam Henderson, I could not agree more. Let's see, he had a whopper of a quote that I don't think is in this paper. It's in one of his other papers. It's the single most fascinating quote I've ever read, but I don't think it's in this one. I will have to save that for another time, but these guys aren't messing around. They know the deal, and I'll tell you what, if you are interested in Alzheimer's, you've probably heard the name Dale Bredesen. I quote his work in my book. I celebrate his work. He's doing some very, very fascinating research in small cohorts so far, but with a dietary and lifestyle intervention to prevent, slow, or possibly even reverse Alzheimer's disease. His stuff's really fascinating. It's very preliminary. We can't hang our hats on it yet, but the diet that he recommends, he calls it keto light. He's more of a higher fat Mediterranean type proponent. He never uses the word like full-on ketogenic. He calls it keto light. I think it's because he's a little scared still of the red meat, for whatever reason. He's an MD. He may still have like one foot in the old, nutritional and medical paradigm, where he's not sort of professionally prepared to go out on that limb and say, no, it's fine to eat red meat. And I think he's especially down on that for the E4s because of the saturated fat issue. But he's very into like no grain or at least gluten-free grains, low grain intake. But one of the targets he has for his research, subjects and for his patients is a fasting insulin of less than 5. Good luck getting someone to achieve a fasting insulin of less than 5 when they're on a 60% carb diet. A small select lucky few humans are able to do that. I mean, we know there are some populations around the world that have very high carb diets that do have low insulin. I'm not saying it can't be done, but if you are already on the path to cognitive decline or Alzheimer's or cardiovascular disease or diabetes, you are probably not one of those people. You are not going to be able to have low fasting insulin when you are flooding your body with glucose all the time. So just a point of interest that this is out there, and I just find it hard to think that somebody could have a very low fasting insulin without the low carb diet in the modern world. Like I said, I'm not dismissing the fact that there are people that live that way just fine. We're ending right now. The website I want to recommend to you if you are concerned about E4 or if you want to learn more is apoe4.info. Apoe4, Apoe4.info. They are the experts. I've already told you pretty much every single thing I know about this topic. If you want to learn more, don't ask me, ask the people on the forums. There's like an interactive forum at Apoe4.info. One of the admins there, her name is Julie, she's a patient of Dr. Bredesen's, and she did awesomely on his protocol. She tailored it to herself. She tweaked and changed some things to work it for herself, but she is doing fabulously. She was sort of on the path toward cognitive impairment, and now she's like a rock star. So that's it. My website is toitnutrition.com. I have a newsletter now, so you can subscribe to that. If you go to toitnutrition.com on the right, you'll see the place to subscribe. If you like these videos, please subscribe to the channel, and please share this video if you think you have some people that might be interested in the E4 info. What else? I will be at Low Carb Denver in March 7th to the 10th. I'm not speaking, but I'll be there in person. So come say hi if you'll be there, introduce yourself. And that's it. I don't have a Patreon account right now. Some people have encouraged me to make one, but until then, if you find my work helpful and you would like to send a little bit of financial support my way, all of this time is unpaid. All of my blogging is unpaid. You can go to paypal.com and send $2, $5, $10, $50 to my email address, toitnutrition@gmail.com, TUIT nutrition@gmail.com. Buy me my next cup of coffee, buy me my next pack of ground beef, keep me caffeinated and well fed to keep making these videos. And thanks as always. I'll see you next time.